Before you embark on your learning journey, it's a good idea to learn how you can navigate through the course interface and make the best use of the available features. When you access a module, you'll first view the landing page, which displays its title and the content structure. You can begin the module by clicking the Start Module button. This takes you to the first lesson. You can also view the content structure for each module in the left panel. Each module is divided into sections, and each section consists of lessons. You can also navigate to any lesson by clicking the lesson title in the menu. Note that you can go through the lessons in any order, and you can revisit them at any point. Keep in mind that to complete a lesson, you must scroll all the way down until you see the button that indicates the title of the next lesson. You can check your progress of the module at 2 levels. If you're looking for a specific topic, you can use the search feature. Videos are played using a custom smart player, which provides several features. The Captions button enables you to switch off or display the captions in one of the available languages. You can also customize the way captions are displayed by clicking on the caption settings. From here, you can increase or decrease the font size of the captions and even choose between different colors and transparency levels for the caption's text and background. If you prefer a faster or slower playback speed, you can change it in player settings. To navigate to other modules in the course, you click the Previous or Next buttons. You can also click the View Full Path button to view all of the modules available in the course. To complete a course, you must complete all of the modules that are marked Required. You're now ready to expand your learning horizons at UiPath Academy. Happy learning! Hello and welcome back to the RPA Developer Training. This is the Excel and Data Tables lesson in the Production Ready Essentials curriculum. In this video, we'll cover some of the key aspects of working with data table variables. We'll create 2 data table variables and merge their values together, and then we'll filter the unwanted columns out. In the end, we'll sort the rows of the resulting data table in ascending order. But first, let's go through the basics. Data table variables store data structured in a tabular form, and that means any information organized in rows and columns. This variable type is the equivalent of a spreadsheet containing cells which are individually identified through the column letter and the row number. UiPath Studio includes many activities that output data table variables. In this demo, we'll focus on the build data table activity, which is largely used to define the structure of a data table. Let's examine the first example to see all the configuration options. The Build Data Table window enables us to set the number of columns in our table and the type of data that they contain. Let's click the Edit button to see more options. The columns can comprise any type of data, as we can browse for types and make the selection that suits our automation scenario. Now, there are some additional column customization options, and we'll take a quick look at them before moving on. The Allow Null checkbox allows for specifying if the column can contain blank cells. Next, the Auto Increment feature only applies to integers, so it's not available for us here. Any default cell value can be added in this field. If we select the Unique checkbox, we can make sure that all the values are different from one another. That can be of great help when dealing with types of data such as user IDs in order to ensure a high-quality output. We can also adjust the maximum length of the value in a cell. Let's click OK to return to the Build Data Table window. We can easily rearrange the columns by dragging and dropping them to the intended position. For demonstration purposes, we used the Build Data Table activity to add values to our data table variables. In business scenarios, however, there are more efficient ways to achieve that. For example, the Read Range activity captures the data in a spreadsheet and stores it in a data table variable. In this demo, we'll work with two predefined data table variables. The first one contains information about the members of a library, their name, unique ID, department, and phone number. The second variable, which is called Overdue Books, contains data related to all the currently borrowed books. The author name, the title, the unique book ID, as well as the ID of the borrower. Next, we want to collect the names and phone numbers of the library members with overdue books and store them in a single variable. To do that, let's add a Join Data Table activity and open the Join wizard. Now, the join type is inner because our resulting data table must include rows extracted from both our tables according to the join rule that we will configure. The first input data table we'll provide is overdue books, as there might be members who borrowed multiple books. The users variable goes in the field below. Let's create a new variable for the output. We'll call it borrowed books. And now it's time to determine the join criterion. We'll select the equal operation and write the names of the two ID columns. And we've just finished configuring the join data table activity, so we can click OK. Let's proceed to the next activity in the workflow. To be able to print our result to the output panel, we'll use the Output Data Table activity, which converts an input data table to a string variable. The input is borrowed books, and the output needs to be stored in a new variable. So let's hit Ctrl+K and name this one Borrowed Books String. We'll also change the name of the activity to Output Borrowed Books to Text for increased workflow readability. And we'll display the content of the variable that we've just created using a write-line activity. And let's run the workflow. The output panel displays the correct results, so our project works as expected. However, there are some unneeded details that we can filter out to prevent clutter. Specifically, the ID column is included twice, and the department one is not relevant. As a result, we'll use two Remove Data column activities. Let's place them above the Output Data Table activity. The first one will remove the duplicate column from the Borrowed Books data table, and let's use the index of the column, which is 6. We'll also rename this activity. And now we can move on to the next one. Once again, the data table is Borrowed Books. And now we can use either the index or the name to identify the column to be removed. So we can type department between quotation marks. And let's run the workflow again. Great! The unwanted columns have disappeared. Now, for the last touch, let's sort the data according to the user ID to make sure that users are contacted to return all the books that they have borrowed. Let's add a sort data table activity right before the output data table one. We need to add the borrowed books variable both as input and as output, and the ID column in the name input field under sorting column. All right, let's run this one more time. And it works. This concludes our video on working with data tables. We'll see you soon, and until then, happy automation! Hello and welcome back to the RPA Developer Production Ready Essentials training. Now that we've covered the basics of data table variables, let's learn how to use them when working with Excel spreadsheets. We'll start our demo by reading data from two Excel files that have different extensions. On this occasion, we'll see which UiPath Studio activities suit each file format. We'll use two data table variables to store and then filter the information in those files. In the end, we'll write the data to a new Excel file. Let's begin. A new project called Filtering Companies Before 2005 has already been created. First, we'll read the information in an Excel spreadsheet that has the .xlsx format, and then we'll move on to a .xls file. Please note that both files are included in the project folder. We'll retrieve the information in the .xlsx spreadsheet using the read range activity in the workbook category. We can drag and drop it into our sequence. For the .xls file, however, we'll use a different read range activity, namely the one in the Excel app integration category. Before adding it to the designer panel, we need an Excel application scope container. And let's rename the workbook read range activity to include the file type in the title. We'll browse for our .xlsx file and then remove the range in order for the entire sheet to be read. Next, we'll select the data table field and press Ctrl+K to create a new variable. We can call it output DT1. Let's move on to the Excel application scope, which will read the .xls spreadsheet. We'll rename it accordingly and browse for the file. Then we'll select Read Range and create a new variable called output DT2 in the data table field. We need to use this variable throughout the entire workflow, so we'll open the Variables panel to change its scope. Alright, now let's quickly open our files to see what they look like. We'll switch to the Project tab, right-click the Data folder and select Open. Now the first file contains the founding year of some companies, their name and their revenue. Here's the second file, which comprises the same type of information, but the columns are arranged in a different order. Okay, now that we've read the data, let's filter all the companies that were founded earlier than 2005. We'll add 2 filter data table activities, one for each variable. Let's rename the first one, and now we can open the filter wizard. We'll enter our variable in both the input and the output data table fields, since the companies founded after 2005 aren't necessary. And now we'll set the filtering rule. In the Filter Rows section, let's make sure that the Keep Radio button is selected. The filtering column is Founding Year. Now this field is case sensitive, so we need to type the exact name of the column. Our operator is less than, and the value is 2005. Notice that 2005 is written with 2 decimal values, as the comparison is made using double integer values. And let's move now to the next tab, Output Columns. This tab provides the possibility to reorder the columns. Let's place the company column first, followed by revenue, and then by founding year. Let's repeat those steps for the second variable. Now once again, the input and the output data table fields contain the same variable. In this file, the column name is different, founding. However, the condition is the same one. So let's go to the Output Columns tab and rearrange the columns as we did for the previous variable. Again, let's make sure that the names of the columns are the correct ones. Now that our 2 variables contain the required data, we need to join the information in them together. Now, since there are some discrepancies between the column names, let's use a Build Data Table activity and create a new variable named Filtered Companies. We'll call the first column Company, leave the string type as it is, and disable blank cells. The second column is called Revenue and holds data of the string type as well. And we've reached the final column. Let's call it Founding Year and set the data type to integer. And next we'll add a For Each Row activity, which fulfills the same role as For Each, but is only used with data table variables. Since we want to collect the rows of 2 variables, we'll use 2 For Each Row activities. Now the first one will add the rows in output DT1 to the filtered companies variable using the row.itemArray method. The method converts the data in each row to an array item and then adds it to filtered companies variable. Okay, let's move on to the output DT2 variable. The steps that we need to complete are the exact same ones. Alright, all the rows are stored in a single variable. The data must now be written to an Excel file. The output folder contains a different .xlsx file, which is filled with some gibberish data. We'll use the write range activity, which must be placed inside an Excel application scope container to ensure that the whole file will be overwritten. And let's run the workflow. Notice that the activities inside an Excel application scope container can be performed while the Excel file is open. And it worked! This concludes our demo on working with Excel files and data tables. See you next time.